Is it recording? All right, we are now recording. We're in lecture 8, guys. This is it. This is the last quarter of the program. We got like essentially one more week, no, 2 more weeks. Well, this week and next week. Well, this week and like a bit of next week left, and then that's it. It's crazy. We're pretty much like almost done. There's still a ton of material that I would like to go through, but yeah, we're approaching the end of this thing. So a couple reminders tomorrow. Homework 6 is due. And so I usually don't do this. I usually let like the TAs kind of like handle this, but I kind of look through the homeworks, and some of you, or a lot of you, are just not submitting homework or just not trying on the homeworks, and I just like what's happening, like what's going on with these homeworks? Why are we not prioritizing these homeworks? Like some of you guys like have straight up zeros from like homeworks 1 to 4. Some of you have like really low scores. Like what's going on with the homeworks? Is it like, are we not showing like enough work? Like what's going on? Because you guys know, right? Like the way to get better at this stuff, it's not, you're not just gonna absorb it like the first like 2 minutes that you hear this and then like you're good. You need to practice it, right? That's what math really comes down to. It comes down to the practice, right? So the practice that we don't have time to do practice in class. That's just how it is because I only have an hour to teach, right? So that means all the practice falls on you guys to do that outside of class, right? I saw over the weekend, none of you watched the supplemental video. So you're gonna be lost on today. I told you guys to watch the video, right? Before today's lecture, but no one watched it. So, I mean, like, I don't know. Thank you. Yeah, caught slacking. I mean, that's kind of like putting it lightly. So now all you guys are gonna be lost and behind for today. Because no, I know I saw no one watch the video. Oh well, so hopefully you guys will watch the video today and we'll be able to use it for tomorrow's quiz, but we'll see. There's a quiz tomorrow. It is on the tests that we've done so far with series, geometric series, divergence test, integral test, P series, DCT. Today, it's on sequences. So I was really harshing last time that sequences and series are two very different things. And we will see on this quiz if you guys are actually paying attention or not, because I've said it multiple times in lecture. You can't treat sequences the same way you treat series and the other way around, right? So we'll see. Can you guys remind me, what do we do with sequences usually? How do we show like what they converge to? What do we use? A couple methods.
Divergence and convergence test.
See, this is what I just said. You can't use the divergence test because the divergence test is for series. So thank you for listening. Anyone else? What do we do with sequences?
Wait, you said sequences?
Is this thing on? Am I not coming through clearly?
Oh no, sorry. It's just like my like speakers are a little busted right now. Like I'm not sure what's up with them. So like I kind of couldn't, like it's kind of quiet for me. I just want to make sure you did say
Do you
sequence.
have headphones?
Yeah, I'm like that's what I was trying to like. I don't know if you saw, but I was like trying to plug them in right now. Like they're AirPods, so I was trying to like get them connected. That's why I was asking if that's what you said.
Yes, I was asking, what do we do with sequences? How do we show that they converge or diverge?
Finding the limit.
Yeah, so we can take the limit of a sequence, right? Taking the limit of the general term, showing some algebra in between, and then determining whether if it converges on a number, diverges off to infinity, or just never settles. If it just like oscillates, bounces back between a number and another number. Is there another way or another technique that we can, deal with sequences? Looking for 2 more things.
Squeeze.
Squeeze theorem. Yeah, we talked about squeeze theorem. Can you sum it up real quick? Like what is a squeeze theorem?
It's the limit of the function you want to find, and it has to be between the 2 limits that are equivalent to each other that are what we already know. I don't know if I explained that well.
Okay, I kind of know what you're trying to say, right? So it's like, if we have an unknown, but we can bound it between two, I guess you can use the word functions, two functions of n, right? That we do know, and those two things go to the same value, then the middle piece will also go to the same value by squeeze theorem, all right? But you do have to take the limit of all three sides if you want to do squeeze theorem. And then the last thing,
It's called L'Hopital.
L'Hopital, when are we allowed to use L'Hopital's rule, Jeremy?
I'm not sure, but I just had that in my notes. I don't remember what it was though.
When it's in indeterminate form.
You need an indeterminate form to use L'Hopital's. What is an indeterminate form?
0/0, 0/infinity.
Nope.
Infinity over infinity.
Yeah, so indeterminate forms are 0/0, infinity over infinity. That's it. They're infinity over 0 and 0 over infinity. I said this last class. These are not, I shouldn't have put the, sorry, that's like a double negative. Not indeterminate. And that's it for sequences. And then, so on this quiz, right? Because I went through the entire quiz with you last class. I don't know if you guys took good notes or anything, but I went through the entire quiz. I told you guys exactly what's going to be on there, right? You're going to be given some sequence questions, and then you're going to be given some of these, right? So you're going to be given a geometric series. What do you remember about geometric series? Don't remember anything about geometric series?
Common ratio.
Okay, it has the form AR to the n, and R is a common ratio. What else? How do we draw conclusions given a geometric series?
If the series look geometric.
And
If R is greater than, yeah, if the absolute value of R is greater than 1, then it diverges.
yep. And then if
And less than
absolute
one,
value
it
is less than
converges.
1, it is the convergent case. Yep. That's it for geometric, right? You can find what a geometric series converges to by using this, but this is only for the convergent case. Please do not just jump to the A over 1 minus R. You need to first state that your given series is geometric and that the absolute value of R is less than 1. If you do not state those two things, prepare to have points off. Then we talked about three things. No, well, in the video included, but I afterwards talked about a couple new tests, right? The divergence test. I definitely talked about this one in class. Anyone remember what this one says?
Remember, it's the first test run, and if the limit as n approaches infinity of the sequence does not equal 0, then it diverges.
Yeah, that way. So what's it? What diverged?
The sum of the sequence.
Good, right? So once again, we're looking at the sequence to give us a conclusion about the series, right? That's how divergence test works. If the limit as the sequence does not equal 0, then the series is divergent, okay? Integral tests, this is kind of wordy, so I'll just kind of say it, right? You're looking for three things on the integral tests: positive, continuous, decreasing function that represents the given sequence, right? If that's true, you can take the integral of that sequence as whatever, from 1 to infinity, or whatever the index values are, and then whatever that integral does, the series does. It like follows, right? So if the integral diverges, the series diverges by integral test. And then if the integral converges, the series converges by integral test. All right. You need to show sufficient work on these integration steps. P series and DCT. I guess since no one watched the videos, I have to explain them real quick here. So please watch the video to like make sense of it after today's class. All right. All right. So for today, we got a lot to cover then. We're going to talk about P series, DCT. That is on your quiz. LCT, which is the limit comparison test, this is not on the quiz, so don't worry about, you're not going to be given a question that forces you to use LCT, but we are going to talk about it today, and hopefully we will get to 10-4, but we'll see. So continuation from last class, we're in 10-3. This one has like all of the comparison tests in it and all that stuff. but I gotta talk about this first, P series. So real quick, what is a P series? It's a series that's in this form. 1 over n to the P. And P is a real number. And we break down P into two cases. P can be less than or equal to 1, or P can be greater than 1. So for example, if I have like 1 over n to the second power, since I think we did this one last class. Did we do this one last class? I don't remember. We used the integral test to prove this one, the sum of this one. But there's this, is phenomena the right word? I want to say it's the right word, but there's this really cool thing that starts to happen, right? You notice that when you integrate 1 over n to the 1, we did this last class. I'll show you. Where's it? When we integrated 1 over like x, right? We found that it was divergent. But then if you think about it, if we integrate 1 over x to the like 1.0000001, like as soon as you tip over 1, it's something really interesting happens. The graph actually gets low enough for the infinite sum to be like a convergent answer. So like, what am I trying to say? Like in the second case, when we did 1 over n squared, we saw that the graph and that the integral actually becomes a convergent answer, right? For the reasonings that we talked about last class. So it's like there's like this zone in between 1 and 2, and you basically find out through the integral test that the tipping point essentially is at like p values of 1. Does that make sense? Maybe. So it's like, so once again, if you like just tip over 1 for the p values, it's the graph actually does converge. So to break it up into these two cases, if p is less than or equal to 1, this is the divergent case. The sum of 1 over n to the p diverges. And then if it's greater than 1, as soon as it tips over 1, the sum of 1 over n to the p converges. All right, I think I explained a little bit more in detail in the video, so if you don't know what I'm talking about, watch the video. All right, so that's P series. Why do we need P series? Because for DCT, which stands for direct comparison test, we need P series to kind of be like the ones that we know, right? They're an example of ones that we know, and then compare it to the ones that we don't. Does that make sense? So let me do. Let me do one quick example here. So I'll call this example. See if you guys watch the video, I wouldn't be doing this one again. All right, so this is a very simple example. It's a very simplified example here. The question is going to go something along the lines of, does this thing converge or does this thing diverge, right? Well, if we just kind of use like common sense, right? I know, like, but like I know if you just like look at this, right? What does this thing like resemble? What does this series look like?
1 over n squared.
Why do you say that? Who said that?
Me.
Who's
Justin.
me? I don't see.
Justin.
Okay, Justin. Yeah. Why do you say that?
I mean, like, if when you make n go to infinity, that -3, it's a constant. It's going to become less and less significant.
Exactly. Remember, we are taking an infinite sum. We're going to super duper high values of n, right? So like that -3 actually becomes insignificant, right? So it like what we're saying is this closely resembles 1 over n squared, but technically they are not the same thing, right? Do you guys see that? So we can't be like, oh, 1 over n squared, if 1 over n squared converges, then the other one's going to automatically converge. You need to, come on, you need to directly compare the two. And this is all going back to, do you guys remember the picture that I drew last class? The one with like, if it converges and it falls below, or if it diverges and falls above. Do you guys remember what?
Yeah.
Do I need to draw it again? I don't want to draw it again. No? Yeah.
Now we're good.
Okay.
I remember.
Okay, good. So. Oh, wait, I think I need to do this. Right? Because that one is gonna be small. Yeah, okay, sorry. Yeah, that should be a +3, my bad. But the idea is the same, right? It behaves very similar to 1/n squared. And the way to come up with this, we're gonna call this like, so we're gonna call this our A sub n, we're gonna call this our B sub n, right? This is gonna be the one that we know. When you do a comparison, right? There has to be something that you know as like kind of like a basis of your argument, right? And then the other thing is the thing you compare it to. You get what I'm saying? So the thing that we know is going to be the one that we come up with. And then the one that we're given, this is our unknown. We don't know. We haven't confirmed this one. You know what I mean? We haven't proven it. You get what I'm saying? Yeah. So so this is what I'm going to do. I'm going to state what I know about my B sub n, right? So I'm going to say that the sum of B sub n converges. And how do I know that the sum of B sub n converges? We just talked about it.
Because a P series test, the P here would be 2. 2 is greater than 1.
Yeah, okay. So you don't have to say all of that, right? You can just say B sub n converges by P series. P series. Right? The P value is 2, which is greater than 1. So you know that this is a convergent series. Make sense? So we have the one that we know. What are we hoping for? If I have a convergent case, what are we hoping that A sub n does?
Also converges.
Can you use the picture thing that I did last class? Remember, if I have a
Oh,
convergent case, go ahead.
Oh, falls underneath it.
We're hoping A sub n falls under B sub n. Does that make sense? For all n values. So how do we show this? How do we show that A sub n falls under B sub n?
I don't know how to explain it, but like intuitively it makes sense because A sub n has a bigger denominator because it'll always be, the denominator will always be 3 greater than B sub n, which means it'll always be smaller.
Yeah, and now you realize like why I had to do +3 instead of -3, right? So
Yeah.
So that's like the wordy way to explain it, but we don't want to write all that down, Justin. Do you? I don't want to write.
Yeah,
it
but
down.
I didn't know how to explain it. in
Right,
a
yeah.
short-
We're gonna use algebra, guys, right? I'm just gonna make a substitution. What does A sub n equal again? It's 1/n plus, n squared plus 3. We want to see, is this less than 1/n squared? So let's just do some simple algebra. Watch, if I multiply both sides by n squared, multiply both sides by n squared plus 3, we get n squared. Is this less than n squared plus 3 for all n? Not convinced? Subtract n squared from both sides. Is 0 less than 3?
I believe.
no,
so.
it's greater than 3.
Last time I checked, yeah, it's true. So you guys know how logic works, right? If this is true, then this is true, then this is true, then this is true. It flows this way, right? Does that make sense? Obviously, this problem is pretty easy. It's very straightforward. You actually knew the answer before we even did anything, right? Because it looks very similar to n squared, but some other problems that you come across, they're not going to be so obvious. You have to kind of figure it out. Okay? Yeah. So are we done yet? Did we get to a
Yep.
final answer?
No.
No. What did we just do here?
We just proved that n squared plus 3 on the denominator just converges too. That's all we proved, right? No? Oh, we proved that, yeah.
Yeah, that's what we're trying to do, right? We're trying to prove that A sub n is less than B sub n. Why are we trying to prove that?
Just show that it converges also. Because it's underneath the curve of B sub n.
Okay, so once again, the question was, what is happening to this guy? Yeah, what is happening to the sum of A sub n? Well, we just proved that B sub n is greater than sum of A sub n. So how can we put it all together now? This is like our side work. This is our side work. So now that we showed it, what can we now state in our work?
So since B sub n is greater than A sub n, it falls underneath the trend of B sub n and it also converges. Is that right or no? I feel like it's the
You
right.
mixed up the letters. Since B sub n is greater than A sub n and the sum of B sub n converges, which we stated before about P series, right? We don't have to say why again, right? But we just know that B sub n converges. What can we now state? The sum of, well, what can we now say about A sub n?
It also converges.
Why? What test did we just run?
A direct comparison test.
This is how DCT works. This is how the logic flows for DCT. Okay? You need to show that the one that you know is, in the convergent case, greater than the one that's given. That's the only way you can say by DCT because it falls under. Yeah? If B sub n diverged, how would that change? How would that change the problem? What would we want A sub n to do?
You want it to be
Something
less than, right?
What's it?
Wait, no. You want it to be
What would we
greater than,
want?
greater than.
We would want A sub n to be greater than the one that we know. Does that make sense? Because we can't make conclusions about things that are below on a divergent case. Are you guys following along here?
Yeah.
Is anyone confused? So, John, what counts as enough work? I need to see the construction of your B sub n. I need to see what your B sub n does. I need to see the algebra that shows that one is greater than the other or one is less than the other, right? You don't need to be like this. If you stopped here, that would have been enough, right? And then I need to see your final statement, right? I need to see, since the comparison holds true and the one that I know is whatever, the one that's given is whatever, and then by DCT. 1, 2, 3. How are we doing? What do you guys think? Is this difficult? Talk to me here.
I'm following along. I feel pretty comfortable with it in class. I don't know if I'll be able to do it tomorrow for the quiz, but it seems good right now. It's clicking in my head.
All right, well, I mean, I warned you guys to watch the, whatever. I'm tired of saying the same thing over and over. So let's do one more example here, but this time, a little bit more, a little more. Okay. I need to move to LCT. I'm running out of time here. So let's just talk about this one then. Eventually, I want you guys to get to a point where like you're given a series and you're like, oh, I know what test to run on this, right? Like your initial thing should be run the divergence test in your brain, right? What happens when we run the divergence test on this? What happens when n goes to infinity?
Approaches 0. Not the
approaches 0, right? But the sequence approaches 0, yeah.
yeah, not, but we don't know about this series.
Right. So since the sequence approaches 0, it's inconclusive. We have to use a different test. Okay, so we think, is this thing geometric? Look at it. Does this thing look geometric? And how do you know?
No,
Why not?
we don't clearly see a common ratio.
There's no A value, there's no R value, there's no common ratio being multiplied on each time. Looking at the general time. So it's not geometric, so I can't do anything with geometric. Integral test, does this thing look integratable?
Yeah.
I guess you could do integral test on this because you could use a trig sub on this, but I don't want to, and I know you guys don't want to do a trig sub either.
I
So
was thinking P series.
yeah, you wanna pick like the most efficient route, right? There may be multiple ways to get to the final answer, but you want to pick the easiest route because if you do the integral test is a long one. I would say like if it really looks integratable and like everything else doesn't work, I would save integral test for last. That's just my personal preference, right? Because when I look at this, I can look at what's going on in the sequence and see what's going on the top and bottom. So the first thing you want to do is look at the growth rates on top and on bottom. I talk about this in the video. Look at the growth rates on the top and on the bottom. On the top, what's going on?
Nothing.
Okay, well, don't say nothing.
Okay, yeah, it stays one.
It's just one. It's one the whole time. But on the bottom, be careful here. How is the n variable being affected? What is affecting the n variable?
Being squared, and also under square root, kind of cancel each other out, and then there's a +4 constant.
But as we go to infinity, is that +4 relevant?
Nope. So
No.
it just becomes n.
It behaves like,
Yeah,
it
behave.
grows like
Yeah.
1 over root n squared, which is 1 over n. What did we just come up with? We just came up with our b sub n. Do you guys see how I did that? So you have to pay attention to the exponents, you have to pay attention to the roots, you have to pay attention to the powers, all that jazz. Anything that's affecting the n. If they're constants, we don't care about them. As you go to infinity, they don't matter. Right? Do you guys see the reasoning? Yes? Do you also see that I'm labeling my a sub n and b sub n? Why am I doing that? Why am I labeling my a sub n, b sub n? Is it because I'm neurotic? Probably, yes, but why else? Why else are we labeling the a sub n and b sub n?
Because it makes your proof at the end clearer.
Well, not just clearer.
To show our work, like our work train of thought, I guess.
Okay, yes, very nice answers, yes. But at the same time, if I give you something crazy looking, do you want to rewrite it every single time?
So we can use shorthand notation.
Exactly, shorthand, save yourself time so that you can just say sum of a sub n instead of sum of 1 over root n squared plus 4. You know what I mean? Because like I said, the later problems, they're gonna be much more complicated, you know? So save yourself some time. But if you do not put these labels on, if you do not put a sub n and b sub n on, your reader won't know which one is which when you do your comparisons and stuff. So you need to state them in the beginning. Some people like to call the one given b sub n and the one that we know a sub n. Some people like to call it backwards, you know? Everyone's got their own personal preference. So you need to make it clear and evident in your work. Got it? Any questions so far? How are we doing? Great. Let's talk about the sum of b sub n here. 1 over n. What do we know about this?
Diverges,
Why?
P series.
Okay, so please, if you're gonna make a claim, make sure to always back it up. That's how math works, okay? In real life, people don't do that at all, right? They just talk until like people are convinced that they're right, but that's not how life works. That's not how logic works, okay? You need proper assumptions, you need proper claims, you need proper reasoning, okay? That's how it works. So we say the sum of b sub n diverges by so 1 over n is actually a very special series. It has another name. It's actually called harmonic series. There's a reason for this, but I'm not really going to go into it. I don't have time for it. So you can say diverges by harmonic series or by p series. It's up to you. It's like a very common series, and it's very applicable in a bunch of different ways. All right, here we go. Ready? So here we go. What do we want then to be true? So I have the one that I know, once again, this is the known, right? The one that I know is divergent. So what do we want a sub n to do?
We want a sub n.
All above.
We want a sub n to be falling above b sub n. Okay, so we're gonna do the same thing. Let's plug them in. Let's see what we get. 1 over n. Is this less than 1 over root n squared plus 4? How do we show this? How do we show if this is a true or false statement? What should we do first?
Probably simplify the right side.
Simplify the right side. How do I simplify the right side?
The denominator.
What do I do with it?
You could
Please, for the love of God, do not say it becomes n plus 2. Oh God, is that what you were gonna say? Oh my God.
No, I was saying we could simplify it. I don't know.
Okay.
And we should square both sides.
Square both sides. Ooh, yeah, I guess that works. right? You wanna get rid of that square root, so let's square everything.
Yeah.
Okay. 1 over n squared is less than 1 over n squared plus 4.
Cross multiply.
Don't, okay, oh, see, Jeremy, you just like crapped all over your previous answer. All right, so cross multiply, all right, that's with equations, all right, this is not an equation. We're gonna say multiply both sides by the denominators, right? So we
Yeah,
get,
but like I was always taught that it's basically an equal sign. So like I was never
No,
like,
I
I know it's
know.
probably wrong,
I
but
know, I know, I know, I know. Okay, we get to this conclusion, and we're like, uh-oh, ruh-roh, what's wrong here? Is n squared plus 4 less than n squared?
Nope.
No, so this is a false statement. What does this mean?
that is it's inconclusive, right?
Ooh, yeah, it actually does mean that. I was thinking something else. I was saying that you cannot use DCT. Unfortunately, you cannot use DCT. However, okay, so just let me pause for a second here, right? If this was a true statement, we could have kept going. We could have said, since B sub n is less than A sub n, right? A sub n also diverges since B sub n diverges. Yeah? You get, does that make sense? That's if we had gotten a true statement. But this is a false statement. So DCT, it's inconclusive. It doesn't work, right? Sometimes you have to double check the thing that you're comparing it to. Sometimes your choice could be a bad choice, you know, depending on the situation. In this case, we chose correctly because this 1 over n definitely behaves very, 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 very close to our given one. Like, think about it, right? As we go off to infinity, this thing right here, it's going to become like 1 over root n squared, isn't it? So it's like, if B sub n diverges, A sub n should probably also diverge as well. Do you guys see what I'm doing here? I'm like speculating, I'm hypothesizing, you know what I mean? So this means we need a different test. We're going to compare, right? We're still going to compare, but we need a different like way to run the test. So this is where today's lesson comes in. This is the next test. We're still in 10.3. It's the test that's shown after DCT. And usually you run this one after you run DCT. Or you can run LCT and it usually works like 99% of the time. All right. So the only catch is LCT, it takes a little bit more elbow grease than DCT. DCT, like the inequalities are very straightforward. You just move things around and it should work out, right? LCT requires a little bit more, not force, but like effort, you know? So I'm still looking at the same example, right? So let me comparison test. I'm still looking at the same example, 1 over root n squared plus 4. We're going from 1 to infinity. And I'm still going to do what I did in the beginning. The first step is exactly the same, right? My B sub n is going to be 1 over n. Because it's still a comparison test, right? So I need something to compare it to. So like I said, the first like step is exactly the same, right? The sum of B sub n diverges by harmonic series. Okay, here we go. How does LCT work? Well, it's in the name. What are we going to use? What do you think?
Limits.
Yeah. So this is what we're going to do. So this was like step 1. Step 2. You're going to take the limit. Oh, wait, I should still be in red. Take the limit of A sub n over B sub n. It's super redundant, sorry. I shouldn't say take. Let's say find. Find L, which is equal to the limit as n goes to infinity of A sub n over B sub n. Does the order matter? No. If you do it right, order doesn't matter. So in this case, A sub n is, this is going to be the limit as n goes to infinity. Do I need the limits on every single step? Yes. It's going to be 1 over root n squared plus 4 all over 1 over n. You guys know how to play with complex fractions? when you have a fractions within fractions? Hello?
You flip the denominator, multiply it by the numerator.
Okay, so you guys learned that. You guys never learned outers over inners? That wasn't a thing?
No, I was
Wait, can you
thinking.
say that again?
Whatever. Yeah, I think did you guys learn keep, change, flip?
Yeah.
Yeah,
Okay, then do that one, okay? I learned outers over inners, but I guess, I don't know. I don't know. Different school district. Anyways, keep, change, flip, right? So you keep the top one, change the division to multiplication, flip the second one. So it becomes n over root n squared plus 4. You guys still with me here?
Yes, sir.
I guess I'll be lenient. You don't have to do this, but I highly encourage that you guys start thinking this way. We want to look at what's going on. We want to essentially like cancel out like the ends if we can. There's this really nice trick. You can force factor. Have I talked about force factoring yet or no? I think I did.
Yeah.
The growth a
Yeah.
little bit. I can force factor out an n squared in the under the square root. Watch, I can change this into n squared, 1 plus 4 over n squared, all under the root. And what's going to happen is an n is going to pop out, canceling with the one on top. Do you guys see that? This is all on the bottom. But you guys see how like the ends are going to cancel out, leaving you with limit as n goes to infinity of 1 over root 1 plus 4 over n squared. Why did I do it this way? This argument is stronger than just saying like it's 1 from the beginning, from the get-go. You know, this way you clearly see that this thing is going to 0. I'm sorry, this term is going to 0, leaving you with 1 over 1. You guys still with me here? So if you weren't paying attention, all I did was I took a sub n, put it over b sub n. I took the limit as n goes to infinity. You can use whatever method you want. You can do algebra like what I did here. You can do L'Hopital if it's indeterminate. You can do what's the third thing? Squeeze, right? Whatever method you want to use to get your result. But depending on our result, it tells us what's going on. Think about it, okay? Just think about it. Ready? So write this stuff down, whatever. Just listen to me here, okay? We are comparing two things, okay? You guys still with me here? We are comparing two things and we're letting them go off to infinity. Yeah? Yes? If the result is a finite number, in this case it's 1. If it was 5, if it was 100, if it was 1,000, if it was whatever, that means these two things are growing at a constant rate. In fact, you can say that eventually they're growing at like the same rate. It's just they're quote unquote spaced apart a certain amount. So think about it this way. Do you guys drive? Do you guys vroom? Anyone drive? You guys ever notice that like when you're on the highway, right? Or on the turnpike or whatever, you're traveling at like 65 miles per hour because we're law-abiding citizens. And then someone else is driving at 70 miles per hour. No, I'm sorry. Wait, no, this is a bad analogy. Okay, just think about the spaces between the cars, okay? So you ever notice that like you're driving at the same speed as someone else, but they're ahead of you? Right?
Yeah.
You guys are still going, but the space between you pretty much doesn't change. That's essentially what's going on here. This 1 or 5 or 100 or a finite number represents like the distance between the two, but you're growing at the same rate because there's no leftover ends. You know what I mean? One's not going to grow faster than the other. Eventually, it'll just like level off and just grow at the same. Do you guys get what I'm trying to say here?
Yeah, I get it.
So what we can say is that if L is a finite number, A sub n and B sub n grow at the same rate, which means that whatever B sub n does, A sub m should follow. Yeah, you guys see that? You guys see how we did that? Is this stuff making sense? So how is this different from DCT? DCT, you are directly comparing the two sequences. I almost said series. You are directly comparing the two sequences. If one's greater than the other, or if the other one's greater than the other, and then like it follows, then it's fine. But if that doesn't work, we need to use limits. And the limit comparison test uses the growth rates of the two sequences to come to a conclusion. Is this making sense? Is anyone lost? Okay, so continuing with this example, right? We say, since L is equal to 1, because we just did all that work before, right? Remember, we got 1 here, right? Since L is equal to 1, and the sum of B sub n diverges, what is our concluding statement?
The summation of A sub n also diverges because of the limit comparison test.
There you go. That's it. This is your final statement for LCT. But do you guys see how the logic flows, right? You could have swapped these two. It doesn't matter, right? You could have said since the sum of B sub n diverges and the limit was a finite number, right? That then you could say your final statement. It doesn't matter. But you need these 3 statements, right? This, in order to say this with the accompanying work. So like you need this line too. You guys see that LCT, like I said, right? It's going to take a little bit more steps, especially finding the limit. That's going to take a little bit more effort. But the catch is LCT actually always works. If your strategy is to go with a comparison test, LCT will always work. It just takes a little bit more time. On the other hand, DCT is much faster, but there's the chance that it may not work. You know what I mean? So it's user's choice. It's up to you. If you just don't even want to deal with DCT and you want to just use LCT, you can, but you'll eat up more time. If you want to use DCT, but then take the chance that you have to take LCT because DCT doesn't work, you can do that too. I would say the best way to do it is just to understand both and just know when to use one and when not to use one. But I mean, to each his own. Do we have any questions on LCT? Are you sure? If you guys look on page 580, oops. At the bottom of the page, there's a box, and it sums it up like this. It sums it up like this, right? So they're just saying like given A sub n and B sub n, L is equal to the limit as n goes to infinity, A sub n over B sub n. Now, the way they prompted it is A sub n and B sub n are just sequences. We don't know which is which. We don't know which is the known. We don't know which is the unknown. So this is why they give 3 results. Ready? The first one is the one we just talked about, right? The first one is the first case is the one we just talked about. If L is finite, meaning in between infinity and 0, and A sub n converges / diverges, then the sum of B sub n converges, diverges, right? We just talked about this. Whatever one does, the other one has to do if you have a finite limit. Yeah, so that's the first case. The second case they talk about is if L is equal to infinity, they say, and the sum of A sub n converges, then the sum of B sub n also converges. The last one is if L is equal to 0 and the sum of B sub n converges, then the sum of A sub n converges. We're gonna talk about this in just a second. You don't have to write this down. You can just like write in your notes, page 580, right? It's up to you. So this is technically the full LCT, but the reason why they talk about these other two cases, all right? Think about it. Ready? Are you guys ready? You guys watching? You guys? Yes? Okay. Look at the limit. Look at the limit. Look at it, right? Look, if I look at this right here and the answer I get is infinity, what can you tell me about A sub n and B sub n if it's going to infinity? What can you say about A sub n and B sub n if the value of it is going to infinity?
A sub n is greater than B sub n.
Yes. Do you guys see that? If it's going to
Yeah, I see it.
infinity, the top has to be growing faster than the bottom. Yeah, yeah, yeah. So what they're really saying in the second statement is, if L is going to infinity, then A sub n is greater than B sub n. Then if A sub n converges, B sub n converges. Do you see how that happens? Do you see how that logic flows, right? And then the other case is if it's flipped, right? If L is equal to 0, which one's growing faster, the top or the bottom? If it's going to
The
0,
bottom.
bottom is growing faster. So that means if the bottom is convergent, the top also converges. Do you guys see how that makes sense? Right? You can actually, can you say the other way? Right? If it goes to infinity, and I'm trying to do a divergent case here. If it goes to infinity, that means the top is bigger than the bottom. So you would want B sub n to be divergent to prove A sub n is divergent. Ooh, did I just lose you guys? I think I just lost you guys on that one.
No, I got it. I'm with you.
You guys are hanging on? Okay.
Yeah, I'm hanging on.
Here's the good news. These two cases aren't very frequent. They don't really come up a lot. It's really this one that comes up a lot in LCT when doing LCT. So don't, like 2 and 3 are literally, it's the picture that I drew on day 1 of this stuff. Remember the picture, right? It's literally just talking, it's a callback to the picture. The reason why they're doing this is because they're showing all values of L, and that's how math works. You need to exclude all possibilities to say if something is true. You know what I mean? So they're saying if L is finite, okay, well, what if L is infinite? Or what if L is 0? Those are the only 2 possible choices for L as well. You know what I mean? So that's why 2 and 3 exist. Don't get too hung up on those. Really focus on the first one, the one that we just did. Okay? Anyone have any questions on LCT? Stuff is so good, man. So good. Let's see. Let me just, oh my gosh, I'm starting to write my E's like summation signs. Oh. Example, I don't know. I think this is 4. Ready? So in the chat. Ah, crap. Give me 2 things in the chat. Please respond, okay? Privately to me. Ready? Given this A sub n, what would you choose for B sub n? And what test would you run? DCT or LCT? So you're telling me 2 things. What is B sub n equal? And then what test would you run? DCT and LCT, and prepare to talk about what and why. Go. Give you guys a couple minutes. Please privately message me so that there is no bias in responses. I would like to hear from everyone. I mean, Oren could be wrong, so I guess there's that.
But you said you want us to type the reason why we chose a B sub n?
Nope. I'm trying to do this real quick here, right?
Okay.
Your B sub n, and then which test you'd run, and then be ready to talk about why. I don't know why you guys are taking so long here. Remember, how do we choose our B sub n? We pick something that resembles the growth rates on the top and on the bottom, right? How do I know I'm doing DCT or LCT? Please answer the full 2 questions, Adlin. Ooh, it's not actually, Justin. The second part. First part's good. Ooh, who's this? Is this? Oh, yeah, okay. Waldo, good. Yep. Please answer both parts of the question, Edlin. Not quite, Jeremy. You got the first part down. No, Edlin, that's not right. For the second part. Mohammed, what's going on? Osman, what's going on? Jeremy, oh no, Jeremy responded, sorry. Dan. You guys just sitting there doing nothing?
Are you the host or the co-host?
I am the host. You're responding to the host. The co-host is my tablet. To be sure. There is a surefire way to know though, man. I said it. It's okay. All right, that's enough. Okay, those of you that didn't respond, thanks for paying attention and responding. B sub n, we look at the growth rate on the top and bottom. This part should be easy. Choosing your B sub n should be very straightforward, especially for this one, right? On top, it behaves like n squared. On the bottom, it behaves like n to the fourth. So it simplifies down to 1 over n squared. Yeah. So we're going to try to run DCT. I'm just going to let you guys know the answer is LCT. But we're going to try to run DCT because we just don't know any better, right? So we want, oh, what do we know about B sub n? What do we know about this? Is it convergent or divergent? How do we know?
Conversion by P series.
All right, convergence by P series, right? Okay, so what do we want? If we have a convergent case, what do we want A sub n to do?
Converge.
What?
We want it to be less than, right?
Thank you. Yes, we want A sub n to fall under B sub n. Okay, we don't know if A sub n converges, right? But we want it. Whoa, that was weird. We want A sub n to fall under B sub n. So we plug them in. 1 over n squared. Is this less than n squared over n to the fourth minus n minus 1? Right, so we multiply both sides by n squared. We multiply both sides by n to the fourth minus n minus 1. We're going to get 1 is less than n to the fourth minus n minus 1. Is this true for every n value? Is this true for all n values?
No.
No, right? If I plug in 1, it doesn't work, right? But it's pretty close, right? If I plug in 2, it should work, I think, right? Yeah, right? 8 minus, right? 6 is, no, 4? No, 6. No, 8 minus 2 is 6, and the minus 1 is 5. So it works for 2 and above. It doesn't work for 1, 2. I didn't give you guys a freaking index. I'm sorry. That's supposed to be 1. Sorry, right? So it doesn't work for all the given n values. That's my bad. I was assuming that you guys would assume it starts at 1. So DCT doesn't work. So you have to do LCT, right? I'm not going to finish this whole problem just for time's sake, but you set up the limit as n goes to infinity of A sub n over B sub n. Does not matter about the order, okay? You get n squared over n to the fourth minus n minus 1, all over 1 over n squared, yada, yada, yada. You're going to get, it should be 1 as an answer, okay? Please don't skip out on the yada yadas, all right? Please make sure you do this. I'm just doing this because of time. But you get, it equals 1 in this case. Will it always equal 1, John? No. You got to watch out for coefficients and stuff like that. Sometimes it'll be 5, sometimes it'll be 2, sometimes it'll be 10, right? If it's just a constant though, that's fine. So how do we write our final statement here? I'll get you guys started. Since
L is a finite number and A of n, oh, wait, no.
and what? Always start with
Since
your
L is a
knowns.
finite number, yeah.
Start with your knowns, right? We know that the limit is finite. What else do we know?
B of n converges.
The
Yeah,
sum,
there's
the sum.
Sum
Sum
of,
of
sorry,
B of
sum
n
of B of n
converges.
converges by P series.
You don't have to say P series again. We could just say it converges because that's enough, right?
The sum of A sub n also converges by LCT.
Thank you. The sum of A sub n converges by LCT. How do you know? Well, we found the limit above. We showed what B sub n was. I'm sorry, the sum of B sub n was, right? So that's enough justification. Like you already showed that work in your work. You don't need to restate it again. You know what I mean? Save yourself some time and effort, but that's it. Any questions on LCT versus DCT? No? Any questions on choosing your B sub n? It's not always going to be a power one. There's an example. There's a great example. It's example example 3 on page 579. Here, I'll just real quick. Example 3 on page 579. The example looks like this. Sum of 1 over root n 3 to the n. Oh boy. What am I going to choose for my B sub n? If this is A sub n, what am I going to choose for my B sub n? It's a 50-50 shot.
1/3 to the n.
So I think that was Justin. He says 1/3 to the n. Anyone else?
1/n to the power 1/2.
Those are the two choices. How do we know, right? You guys see why those are the two choices, right? It's either this one or it's either this one. How do we know which one to choose?
3 to the power of n grows faster.
Yes, he was listening. Thank God, right? We pay attention to what grows much faster. Because if you think about it, when you have an exponential function, yeah, in the beginning, it grows slow. But as you go off to like a couple more index values, it's going to start exploding up much faster than a root, right? Think about it. A root function looks like this. Exponential function like does that, right? So the red is going to definitely take over in terms of controlling the behavior, right? So, so our B sub n choice is actually going to be 1/3 to the n. But that's not a P series, John. What? I don't get it. How do we? What are we gonna do with this one?
Turn it to 3 to the negative n.
Let's take it to someone else. It's we're running out of time, guys. It's geometric. Oh, that was a pity-o. Yeah, it's a geometric, right? Listen, the sum of B sub n is geometric, and the absolute value of r is less than 1. Do you guys see what I'm doing here? Right? This is the first part. This is the second part that you need, right? So the sum of B sub n is
Convergent.
thank you. It's convergent. Man, you guys really need to study for this quiz tomorrow, right? It's convergent. Do I need to find out what it converges to?
Not for the LCT.
No,
Yeah.
you do not need to find out what this converges to. You just need to know that it converges, right? Questions asking about a completely different series. So all you need to figure out is, does it converge? Boom, you figure out if it converges. If the question specifically asks, what does the geometric series converge to? Then you find it. Then you do the A over 1 minus R. But this question is not asking for that. So you just say you have your conclusion, right? B sub is convergent. We want what? What do we want to be true?
A sub n to be smaller, fall under the graph of, well, fall under B sub n.
Exactly. We want A sub n to fall under B sub n, right? And we test it out. 1/root n 3. You guys can finish this problem. All right, I'm just gonna. You guys can handle this problem. All right. If DCT doesn't work, use LCT. Yeah. Gosh, man, I'm so over time. I didn't even get. There was a whole nother section I wanted to get through. Something 10.4, absolute and conditional convergence. I have to push this to next class, which sucks. Because tomorrow you guys aren't gonna have time to go over anything because you're taking the quiz. All right, I guess we're just gonna have to rush it on Wednesday. I don't know. I really, guys, I had to sacrifice a lesson for you guys because you guys didn't watch the video. Please take advantage of my kindness and study, watch the video, go through your, do you guys know about homework? Like, I know this is what you guys have been doing because Gina's been telling me that she's been getting the submissions like minutes before it's due. So that tells me that you guys aren't starting your homework like when she signs them. You're not in real fall calc classes, you cannot wait till the last day to do the homework. You have to do it you have to do it over like the couple of days, right? So if we assign you homework like on Monday and it's, I'm sorry, Tuesday, Thursday, whatever. If we assign you homework on a day and it's due like 4 days in advance, you should be waiting until the third night to do it. And then being like, oh, they didn't teach us right. No, you didn't do it. You didn't get ahead of it in time and you didn't reach out and ask for help in time, right? So you guys need to get ahead of this homework stuff, especially those of you that are not doing your homeworks. Because you're only hurting yourself then, right? The homeworks are practice for the quizzes, are practice for the midterms and the final, you know? So if you're screwing up on the homeworks, then you're gonna screw up on the finals instead. Yeah. All right.